Okay, hello everyone. Now that we've been working with complex numbers, we're going to have to take a look at certain properties regarding complex numbers and the conjugate of a complex number. And let's just go ahead and start by defining that if z is going to be equal to a plus bi, then this notation here is going to represent the conjugate of z, which is a minus bi. So there's certain properties that we're going to have to take a look at and recall and commit to memory. And one of them, for example, is that the conjugate of z, if you take the conjugate of z, you get z. The second one says that if you take the conjugate of z sub 1 plus or minus z sub 2, that's exactly the same thing as taking the plus or minus of the conjugates of z sub 1 and z sub 2. The third one says that if you take the conjugate of z sub the conjugate of the product of z sub 1 and z sub 2, that's exactly the same thing as the product of the conjugates. This one here says that the conjugate of the quotient is exactly the same thing as the quotient of the conjugates. And this one here says that if we go ahead and take the conjugate of z sub n, z to the n power, that's the same thing as taking the conjugate and raising it to the n power, for n is an element of z positive. Now, let's go ahead and take a look at how we need to go ahead and be able to prove some of these properties. And remember that in order to prove them, you must use the general form of the complex number z is equal to a plus bi, and you cannot use any particular values for the parameter, because otherwise you're just looking at specific values of z. So let's just go ahead and take a look at an example here, and let's say that we're trying to prove this first property here, which says that the conjugate of z is just z. Now, if I go ahead and try to prove this, the first thing, of course, is I have to say, well, what is z? And I'm just going to go ahead and let that be equal to a plus bi. Then I go ahead and just take a look at the left and the right hand sides and just substitute accordingly. So therefore, the conjugate of z, which is going to be a minus bi, and taking that and finding the conjugate of that should be equal to a plus bi, because that's what z is. And sure enough, the conjugate of a minus bi is a plus bi. So you have the left and the right hand sides being equal. You've proven what you needed to show. Let's go ahead and take a look at this particular situation. What if you were to prove that z conjugate times it by z is a real number? Well, again, let's go ahead and just say that let z be equal to a plus bi. Then we know that z conjugate times it by z is going to be a minus bi times by a plus bi. And again, all I need to do right now is FOIL. The FOIL is going to produce no middle term here, and I have a minus b squared I squared, and remember, by simplifying I squared to -1, we have a squared plus b squared. Now, that doesn't necessarily say that this is a real number yet. What we need to go ahead and say is that the imaginary part of z conjugate times it by z, of course, is 0, because when we go ahead and multiply this, we have no imaginary part. And therefore, we know that z conjugate z is real. Okay, so just to go ahead and wrap up here, if we go ahead and take a look at z, we can go ahead and use this notation for z conjugate. We have properties that are as a result of the interaction between z and z conjugate. And then we need to be able to prove some of those properties by making sure that we use the most general form of the conjugate, of the complex number. Okay, so we'll go ahead and take a look at some of these properties and prove some of them as well. And let's see how we do. See you later. Bye-bye.